This is AQA GCSE Chemistry. It is a dual award and therefore also triple award topic, and it's the second video in the bonding chapter. It is quite a long video. There's a lot to consider on this. I am going to recommend that you do pause and have a go at different activities rather than just watching it through. That's going to help you to realise what you're confident on and what you might need to work on a little more. But let's get straight to it and have a look. The objectives: we need to know what chemical compounds are, how elements form compounds. We're going to look again at the formation of positive and negative ions. We've already seen that back in chapter 1. And knowing how group 1 elements bond with group 7 elements. So first activity here is to work through some electron configurations. And we've got lithium and sodium, 2,1 and 2,8,1 respectively. Both of them are in group 1, both have 1 electron in the outer shell. If I then take a look at magnesium and calcium, they're both in group 2. Their outermost energy level has 2 electrons. And fluorine and chlorine have 7 electrons in their outer shell, and they are in group 7. Some more revision here, things to reconsider from earlier within the course. And this table at the top is absolutely fundamental to any learning that you're going to do in chemistry. You need to know that the proton is positive, the electron is negative, the neutron is neutral. So +1, 0 and -1. You need to know the relative mass of the proton and neutron are equal, and we give that a value 1. And the electron is negligible in comparison. It's around 2,000 times smaller. We then have got to remember protons and neutrons are found in the nucleus, but the electrons are found in shells around the nucleus. Still revision of chapter 1 here, but number of electrons in the outer shell I've already just spoken about with the previous task. Lithium, sodium, potassium all have 1 electron in their outer shell. Fluorine and chlorine have 7 in their outer shell. If I then put their group numbers in, we can see group number is equal to the number of electrons in the outer shell. We're now going to revisit the idea of how ions are formed, and remember that lithium with 1 electron in its outer shell, to get a full outer shell, the easiest way to do that is to lose 1 electron. Now, if you lose an electron, you end up with a charge of +1. Group 7, they would each gain 1 electron, and that would give an overall charge of -1. So there are some examples of this on videos in chapter 1 and chapter 2, but I am going to go through them, give you a chance to work through and see how you do. It's a very long-winded way of finding the charge, but it does allow you to see precisely why sodium in this case is +1, for example. So if we go through and answer the questions in turn, protons in sodium, there are 11 of them. There are also 11. We know that from the atomic number on the periodic table that's provided. We know that protons have a charge of +1 and electrons have a charge of -1. So if I've got 11 of each, that will be a charge of +11 and -11 respectively. And that means my overall charge on an atom, and this is true for any atom, is 0. How could a sodium atom most easily get a full outer shell when it could lose 1 electron? And this is where we start to see how ions get charge, because that now means it has 10 electrons, which would have a total charge of -10. However, it still has 11 protons. Protons are not lost or gained in chemical reactions, and my total charge from them is +11. If I take my -10 and my +11, it gives me an overall charge of +1, so my ion is Na+. Here's another example for you to try. And for fluorine, fluorine's atomic number is 9, so there are 9 protons. Because there are 9 protons, there are 9 electrons. 9 protons has a charge of +9, 9 electrons has a charge of -9. So the overall charge with 9 of each will be 0. But fluorine, to get a full outer shell, would need to gain 1 electron. And that means it will have 10 electrons with a total charge of -10. But it will still only have 9 protons with a total charge of +9. So if I look at my total charge from electrons and total charge from protons, -10 and +9 gives me an overall charge of -1. So the formula of a fluoride ion is F-. Going to look at this in a slightly different way now. Have a go at the activities as you see them. And to begin with, this is fairly straightforward. We remember the first energy level holds 2 electrons. Each subsequent one holds 8, is as much as we need to know at GCSE. So I draw those out and I get my sodium with 281 and my chlorine with 287. Now have a think about this question. So we know here sodium wants to lose 1 electron and chlorine wants to gain 1 electron. Well, it makes sense that the sodium will give one of its electrons to chlorine. Now we need to think about what they will look like after the electron transfer has taken place. Well, sodium has lost 1 electron, so it's now 28 rather than 281. The electron it's lost has joined chlorine, taking it to 288 instead of 287. But we've got to reflect the fact that these are charged. Sodium losing an electron is now positive, and chloride, after gaining an electron, is now negative. And then we have a question here about what an ionic bond actually is. Why is there an attraction between the ions formed between the Na plus and the Cl minus? And we'll keep this really simple. It's because opposite charges attract. We know that from elsewhere within science. We know it in physics. We can equate it to north and south poles. Opposite charges attract, and it's that attraction between the ions that actually forms the basis of the ionic bond. And we can see there a positive sodium and negative chloride ion. Of course, they are going to be attracted. So a chance for you to do all of that with 2 different atoms, lithium and fluorine. So let's start off by drawing them out. Lithium is 2,1, fluorine is 2,7. Lithium wants to lose 1 electron, fluorine wants to gain 1 electron. So lithium transfers its electron to fluorine. That then means that the structure of lithium, the electron configuration, is now 2 rather than 2,1. Fluorine is 2,8 rather than 2,7. But lithium has lost an electron, so it becomes a positive ion, and fluoride has become a negative ion because it's gained an electron. That takes us to the end of this video. Thank you for listening, and goodbye.